All right, so let me just go ahead and make a blank workbook. I want to save changes to that, yes. And let's just suppose that it's the 1970s. How old were you in the 1970s? That's really funny. I know you weren't born because I was like 2 in 1970. So let's just look up 1970s computer terminal. The 1970s is when businesses are really starting to think, wow, you know, these computers, we can really do great things with these computers. These so-called computers. But this is what a computer kind of looks like in the 1970s. Notice there's no mouse. You know, you've got a monochrome screen. You've got, you know, probably 80 columns by 25 rows to work with, and it's all characters. This one's great. I don't know what that one is, but that's just beautiful terminal. And so let's suppose that, you know, you are like a manager of a bank. It's 1970, and you've read about these so-called computers, and you think, you know what? Computers could really make our bank run better. So you decide we're gonna computerize the bank. It's kind of hard for us to imagine running a bank without computers at all, but they used to. You know, for hundreds of years, they had banks without computers. In fact, you know what they did? They would like close the bank, typically, once a quarter. This is a normal work day, but it's closed. Why? Because we're accruing the interest on the accounts. We're going account by account, doing the hand calculation to say we've now added that much more interest, you know, either to your loan balance or to your bank balance. It takes a whole day, you know, to just everyone. Sorry, bank's closed today. We're applying interest. So you think, wow, you know, we could get these computers, we could do all that stuff automatically, all that stuff we used to do by hand. This would be great. All right, so here's our task for today, is to kind of introduce this idea. Suppose, you know, that this is the computer you've got to work with. Let's design an interface to be able to do a deposit. Someone's going to come in, they're going to bring money, and they're going to deposit it. This is cash deposit. Don't have to worry about a check or anything. Cash deposit. What's the screen going to look like? Now, you have to realize that a lot of things about computing that we take for granted today, they're not things we would have taken for granted in the 1970s. For example, how long does it take to get the information from the computer to the screen? Network latency, in this case. We don't even think about that anymore because it's so fast. But you know, that takes the transmission of the data takes a while. Another thing we don't often think about is how long does it take to read data from the hard disk? Like to just go, there's information out there on the disk, we got to retrieve it. We got to find the data that we're looking for and retrieve it. Those were things we had to take into consideration in the 1970s because, you know, that could make the difference between this transaction taking 10 seconds and taking 30 seconds. And is that 20 seconds a big deal? Yeah, you know, if you've got a line of people here in the bank and you're adding an additional 20 seconds to everything that they do, that's something you'd like to be able to reduce. And so, you know, we have slow data transmission and we've got slow data access. Now, let's design a screen. And here we got all of Excel and a mouse and everything, but let's just suppose that we've got a blank screen. Let's make a blank screen. We'll even make it black. Black screen, and we'll make white letters, no green letters. Okay, excellent. What information do you need to be able to do a deposit? This is the cash deposit screen. What are you going to do? What's it going to look like? What information do you have to have? Okay, there's going to have to be an amount. So amount, and maybe, even though, let's go ahead and like make this some kind of a colored box that we can put the information into here. Oops. We'll put the text in black and we'll put the kind of a light green background. There we go. All right, there's amount. Is that it? What else do we need? Well, we got to know what account it goes into. So what information do we need to be able to get the account? Say it again. Okay, so account number. The routing number, what does the routing number do? The routing number gets to the bank. So once we're at the bank, we're just making a cash deposit here in one of our accounts. All we need is the account number. So we got account number. All right. Anything else? That's one of the great things about the computer. We don't need the date. The computer knows the date. We don't have to write the date. The computer just knows the date. So we don't have to enter the date. It's just there. This looks like, this is it. This is the kind of minimum that we need. And in the 1970s, what are we after? The minimum. We really are. So, someone's going to come in here and we'll say, great, you're going to deposit $100. And we're going to put it into that account. Maybe the account number is not that long in the 1970s. Now, let's talk about, and then we'll process that, right? So we've collected the information. All we have to do is, and what we're going to take that cash, we're going to put it in the drawer. We just have to remember that that is going to increase that particular account by $100. That's the part that we have to remember, because we're not actually going to take that $100 and put it in someone's pile in the back room. It just goes into with all the cash. So what are the problems that could happen here? What's the threat? Yep. Oh, this is all we're talking right now is deposit. Yeah, so withdrawal would be a different process. Yep. Oh yeah, you could type the amount in incorrectly, or you could type the account number in incorrectly. Now, we'll probably be able to print out a receipt, to give to the person, and so they'll be able to see the amount. The truth is, they're not going to know their account number, so even if we print the account number and give it back to them, they're going to look at it and go, great. They might look at the amount and go, hey, you said $10, I gave you $100. Oh yeah, we'll fix that. Maybe not the other way. If we gave you 10 and you said it was 100, maybe we'll just walk out, I don't know. But the account number could really be a problem. So it's 1970s. How are you going to give some assurance you got the account number correct? What can you do? Any idea? Okay, go ahead.
I don't know if you make it so that the numbers themselves, that combination of numbers is valid some way, like the stats.
Yes, okay, so you're talking about a check digit, and that's exactly what I want to get to. So let me hold on that for just a minute. Other thoughts? There's another thought over here. Go ahead.
If you know an account number can only be like 5 or 6 digits, then you can create a validation tool around that.
Okay, good, yeah, and these are things that we can do in the 1970s. Typically, one of the things that comes up is, hey, why don't you just go ahead and once you put that number in, actually verify that it's the person, go back to the database and use that number and find out who it is. It takes too long. We can't afford to do that in the 1970s. But these things that you've come up with, these are things we can do. We can say, listen, we know this account number has to be 5 digits. Our account numbers are 5 digits. You give us 6 digits, no good. But now so yeah, and we can do that quite without much computing resources. Remember, we don't have much computing resources. Your phone probably has more processing power on it than the state of Utah had in 1970, right? I mean, that's kind of the scale that we're talking about. So, okay, so you had a suggestion over here. You thought, what can we do? And that's exactly what they did. In the 1970s, they came up with this idea of a checksum. Here's what they did. They said, we're going to take these numbers, we're going to add them up. So that would be 18. We add those up, and we will just put on, as a part of the account number, 2 digits on the end. That's just the sum of the other digits. So now, if we've made a mistake in the first 5 digits, then it's not going to produce this proper checksum. So we can just look at the first 5 digits, add them up, see if it equals the last 2 digits. If so, it's well formed. They would have to make a counterbalancing mistake, a mistake in the first 5 that is balanced by another mistake in the second 2, and the chance of that happening pretty rare, except for one occurrence. There's one common mistake that this would not protect against. What is it? Yeah, if I transpose any 2 numbers, which is one of the most common mistakes that we make in keying data, the check digit is not going to change the check digit, what's called the checksum. And so this is like a first step on the way to the idea of what's called a check digit, and that's where we're headed today. A check digit, then, it's called a check digit because, you know what? If we could get down to typing only 1 digit here instead of 2, that'd be better. It's only adding 1 character. And what we want to do is we want to have some algorithm that we can apply to the actual identifier of the account number, apply some algorithm to it, and have it produce that check digit such that any single number typed wrong will we'll be able to know that's no good. And any two sequential numbers that are transposed, that it will also, would not produce the same check digit. And so that's what we have. And in fact, any time you've got an account number today, account number that's going to be keyed in, it almost always has a check digit built into it. So it's not, there's part of it that's not necessary to identify your account. It's just there to make sure you've typed the thing in correctly. And so we're going to talk about the check digit in the context of the International Standard Book number. But while we're here in the banking domain, I just got to tell a story about a former professor at BYU. He claims to have been a former professor at BYU. I'm talking about a guy named Frank Abagnale Jr. Have you heard of him? Heard of him? Would you say he's awesome? Now, he works for the FBI now, after he got out of prison. But his very first financial fraud, he did some frauds like credit card fraud. I'm not sure I'd really call him a financial instrument fraud, but the first financial instrument fraud, took advantage of kind of a weakness in banking procedures at the time, and it was like 1970s. So what he found out is that when Edna came in to deposit her paycheck or her Social Security check, she came in, she picked up a deposit slip from the counter, just a blank deposit slip. She wrote her name on it and the information about the deposit. She took it up, and the teller would look up her account number, even though there's a place on the deposit slip to write your account number. But he realized that if the account number is already there, they didn't do the lookup. They just typed the account number in, just a screen like this. Probably some other screen that say, okay, we've got to look up your number, but we ultimately have to come here and type it in. And so he goes into the bank and he takes out a stack of these deposit slips. He takes them home, rolls them to the typewriter, and he types in his account number on every single one of them. The rest of it's blank. He takes them back and puts them in the bank right there on the counter. And so now when Edna comes in, she takes the slip, she fills it out the same way she does. She puts her name on it, maybe her address, takes it to the teller looks at it, types the account number in, makes the deposit, and goes on. After a couple of weeks, he closed the account, took the money, and walked away. I don't know how much it was. He would later, of course, he would later become a famous fugitive, ultimately get caught and do time in prison in multiple countries, France, Sweden, United States. But now he has a great career working for the FBI, trying to stop other people from doing what he was so successful at. He was actually the first criminal to realize that you could seriously delay how long it would take for a check to clear if the routing number sent it to the wrong side of the country. So he's like printing checks. From one of the places he defrauded was Pan Am, the airline. He printed checks. This Pan Am, employee, paycheck, and the account goes to a particular bank, but the routing number takes it to someone else on the other side of the country. So it gets over there, and they're like, this doesn't belong here. And they put it back into the route, and it comes right back. And, oh, guys are making a mistake in the routing number. It would take almost a month for those checks to clear. So we could go and go to a bank. How does a bank know your check has cleared? The same as today, by the way. How do they know? It didn't bounce. How long does it take for a check to bounce? It takes 3 or 4 days. And so, deposit this money. We'll put a hold on it. If it hasn't bounced in 3 or 4 days, we think we must have cleared. And he found a way to make his checks take weeks before they would bounce. And so they would release the funds, he'd spend them, and then disappear. All right. He claimed in his autobiography, he claims to have actually taught in a psych department here at BYU. Whether it's true or not, I don't know. The university denies it, but. Okay. So our job then today is in VBA, to write the algorithm that will calculate the check digit for a 10-digit ISBN. So you're familiar with ISBN. Let's see. Let's just go to Wikipedia, International Standard Book number. Right, here's your ISBN. Is that a 13-digit one? That's a 13-digit ISBN. 978, there's 13 digits. The last digit is the check digit. And so there's some algorithm that we apply to these first 13 numbers, and then it will produce the proper check digit. We just compare what we calculated off the first set of numbers to the check digit, and if it's right, we say that's a well-formed ISBN. That's where we're going. In fact, there's a time when we were moving from the, oh yeah, here it is. So this is a 10-digit ISBN. So up until When does it say here when 13-digit came around? 2007 is when we moved to the 13-digit ISBN. So there's a time where you had both books actually printed both a 10-digit and a 13-digit while people were transitioning from one to the other. So you'll notice here that the actual identifier part of the number is the same, 81,752, or anyway, 81,752. The number's the same. Check digit's different, and it has a prefix on the front that turns this ISBN into like a more standard product code. So it kind of goes into the space of all like SKUs, stock keeping unit identifiers. But the identifier of the book is unchanged between the two, so you can kind of see that. So different algorithms. In fact, this page talks about both algorithms. But what we're going to do today is we are going to implement this algorithm, the ISBN 10-digit algorithm. Here's how it goes. I love this. I should just give this as an exam question. Each of the first 9 digits of the 10-digit ISBN, excluding the check digit itself, is multiplied by its integer weight descending from 10 to 2, and the sum of these 9 products is found. The value of the check digit is simply the one number between 0 and 10, which when added to the sum means the total is a multiple of 11. That's enough to figure it out, isn't it? You know, probably with some work. Fortunately, they give us an example through right here. So here's the idea. We've got this check digit right here, this ISBN right here. We don't know what the check digit is. We take the first number and we multiply it by 10. So the first number is a 0, we multiply that by 10. We take the second number, 3, we multiply it by 9. And so as I look across this sequence here, I've got the ISBN, 03064, 03064. And then the second part of this sequence here is just 109876. So I take the first number multiplied by 10, add it to the second number multiplied by 9, add it to the third number multiplied by 8, and so forth. All the way down to 2, I get that sum. And then I just have to figure out what number, if I add it to that sum, will make the product of that number and the new number I've added a multiple of 11. And we'll do that with a function called mod, which we'll talk about actually when we get to it. But that's where we're headed. Shall we go ahead and do it? Let's do it. So back to this beautiful green and black screen. And let me come into VBA. So I will insert a user form. No, we're not getting user forms. That's coming after the midterm. I will insert a module. Now, so far, everything that we have written in VBA has been a sub-procedure. We want some code we want to say, we can put it in a sub-procedure. What's a sub-procedure? A sub-procedure is a block of code that runs, right? We got all these statements together, so we want to run this as a unit. Just run this set of statements. A function procedure, which we're about to create for the first time. Now, remember, we talked about functions last time we were together. We looked at all in string and left and mid and replace and split. Those are all functions. What do functions do? You give it some values, it gives you back a value. What we're going to see now is that we can write our own functions in VBA. And in fact, those functions can actually be used directly from a cell. You can use them from a cell inside of Excel as well as calling them from other places of VBA. And so it's just exactly the same thing as a sub-procedure, except when the function procedure is done, it sends a value back to wherever it was called from. So we're used to starting off with sub and giving it some name. Now we start with function. We give it some name. The name, I'm going to call it is valid ISBN 10. That's a great function name. Now, inside the parentheses, I've got to give it something. I've got to get it some kind of candidate ISBN to work with. I'll just call it the candidate. Now, what should we take that as? What should we bring that in as? Any thoughts? That's good. I like it. String. Why should it be a string? Okay, so the comment here is, it is a series of numbers, but you're not representing a quantity. The whole reason that we keep numbers as numbers, we're going to do some math on it, right? Like you're never going to take the what's this ISBN divided by 3? That doesn't mean anything, right? And so, you know, string is a good choice. There's actually a really important reason for the 10-digit ISBN as for why it would need to have why it would need to be a string. And the reason is, let's look at this. We are looking for a number. We've got to add some number to this that makes it a multiple of 11. So what could it possibly be? What numbers might I have to add to make this into a multiple of 11? Could be 0. It could actually come up as a multiple of 11. Could it be 1? Yeah, 2, 3, 4, 5, 6, 7, 8, 9. Could it be 10? Yeah. If I'm just one number above a multiple of 11, I've got to add 10 to it to be able to make it a multiple of 11. What's the problem with adding 10 to it? Yeah, it's a check digit. It's a single digit. How do I write the number 10 with a single digit? No, 0 is 0. What do you mean x? X? How is x? X doesn't mean 10, does it? In Roman numerals, it does. X means 10 in Roman numerals. And so that's what they said. You know what? All right. Well, this is a pretty simple algorithm, but it could actually possibly be a 10. And so we're going to make that to be a digit. It's going to be x. So some 10-digit ISBNs, if you look, roughly 1/10 of them have an x as the check digit. Have any of you ever worked like in a bookstore or in a place where you have to type in ISBNs? They often have in these domains a 10 keypad that actually has an X on it, so that you can just type an X in, right there with 10 keypad. Okay, so it has to be a string because if I'm passing in, I could have a valid ISBN that needs to have an X on it. Plus, whenever I see ISBNs, they typically look like this, where they've got either spaces in them or some kind of hyphen. They're actually kind of shown because these are different groups, right? This part identifies the publisher, this part identifies the title from that publisher, this identifies some group, I don't know what it is, but so there's often like hyphens or spaces or dots kind of put in there, and we would like to be able to take those and deal with them. Now, here's one thing that's different between a function procedure and a sub-procedure is that function procedures, well, they return a value, and that value has to be typed, like a variable is typed. And so how do I give a variable its type? I say as some type. I do the same thing for a function. To give this function a type, I say as, and I'm going to give this back as a Boolean. True or false? So the idea here, you're going to call this function, you're going to give me an ISBN, one that you want to validate, and I will send back true if it's a valid ISBN, false if it's not a valid ISBN. Okay, so help me out. How are we, even before we get to the calculation here, what could we do? We could look at this and say, that's not a valid 10-digit ISBN. That is for sure not a valid 10-digit ISBN. What's one case where you can look at it and say, that's not valid? Without doing any calculations. Yeah, is it 10 digits? You give me 9 digits, it's not a valid 10-digit ISBN. You give me 11 digits, it's not a valid ISBN number. Now, problem here is that we want to be able to accept hyphens, spaces, or whatever. We want to be able to look at anything in this string and say, listen, if you gave me something that's not 0 through 9 or an X, just get rid of it. So let's start with that. We'll make another function that starts off by doing that. So let me do this. I'm going to declare variable in here. I'm going to call it dim. I'll call it CN, the candidate number, as a string. And I'm going to set the value of that, CN equals, and here's what I want to do. I'm going to write another function that I can just send the whole candidate down to, and it will send me back just the valid numbers. And so at that point, I can check the length of it and know, am I good? So why don't we call this valid digits? We haven't made this function yet. We're about to make it. And I'm going to pass the candidate down to it. So whatever the user passed into me as the candidate, I'm just going to pass that down to valid digits. Question?
So you're putting the dimension of candidate in the function. Is there a particular reason you have decided to just put the candidate and then get below?
Here? Yes. So the question is, why am I declaring the variable here? And the answer is, I'm going to come back to this, make a new sheet. And I'm going to have some ISBN. I'll go ahead and put in here the one that we're going to be calculating. Which is right here. So I'm gonna have that sitting here in a cell, and then I'm gonna want to say this equals is valid ISBN 10, and I want to send that value to the function. And so that's why and I want this to return. Yeah, so it's not quite there yet. That's okay. So I want to be able to receive that value. So I don't want to have to come in here and actually change the value of the ISBN that I'm calculating. I don't want the user to have to come in here and change the code. I want the user of this function just to be able to supply it as a value and have the function operate on the value, and that's what we're doing here. So we're setting up a variable here. It's a special kind of variable called the parameter. Parameters get their value when the procedure is called. And so that's why we're setting it. Does that answer your question? Could I put candidate where? I could, yeah, so I could put it here and then dim it here as well.
Yeah, but not there as a string in that.
So, and then come here and say dim candidate as string. Let me go ahead and put that in. The answer is no. But that's the question. Is this legal? And the answer is no. So the reason that it's no is because I have declared a variable here, and in not giving it a type, what type does it become? It becomes a variant. So I have a variable called candidate of type variant. And now I'm trying to make another variable with the same name of type string. And it says you can't have two variables with the same name in the same scope. I can have two variables with the same name if they're in different procedures, but not in the same procedure. In fact, that's the error that I'm getting here. So let me come over here, leave that like that. And so I'm gonna put this back to as string up here. And that's the way we have to do it. Okay, so now I'm gonna make another function. And I'm gonna call it valid digits. I'm gonna take some data in as a string, and it's gonna return a string. Now, one of the things that takes a little bit of getting used to is the fact that the variable name that we use here does not need to be the same variable name here. So this is gonna be, this will be a particular number. I'll just put it here so we can see it. I think I'm gonna put it here. And so if I was to call isValidISBN, and then in parentheses pass it this value, then this value gets stored into the variable called candidate. Later, when I call valid digits and I pass it candidate, it goes, oh yeah, this number is 0306 whatever. I'm gonna pass that same value into a different variable called data. And here, it's the same value, I'm just passing that value around, and it'll just go by a different name here. Could I have the same value in two different locations in memory, each with a different name? Yeah. And so the fact that we have different names here is totally fine. All right, here's what I want to do. Help me figure out, talk to me in English. How am I gonna take this, and what I want to return is, if I get passed in this, I want this to return this. So tell me what I should do. Go ahead. Okay, so that's a good algorithm. So what you said was, I said I got to look at every single character that gets passed in, and I have to look at that, and look at it one at a time. Look at the first character and say, is it a number? Yes or no? If it's a number, great. If it's not a number, does it happen to be an X? If it's an X, great, that's one that I want, that's a keeper. And then, keep it somewhere, and then look at the next character. Is this one a number? No. Is it an X? No. I don't do anything with it, just throw it away. And just accumulate the ones that meet that criteria. Is it a number? If not, is it an X? All right, I like it. So to be able to do this, let me declare a variable in here to keep track of the value that I'm that I'm getting ready to return. In fact, maybe I'll just call it my return ret val. This is the value I'm going to return as a string. What value is that variable going to start off with each time I call this function? Every variable in VBA starts off with a default value. That's not true in many languages. Many languages, whatever data is there in memory is just still there. But in VBA, when I declare a variable, it initializes that variable and puts a value. What's it going to be for a string variable? Yeah, empty string, just a zero-length string. So there's nothing in it, so that's good. So let me also just declare x as an integer. Now that means I'm assuming, I'm going to use this to keep track of which digit I'm looking at. That means this will fail if I pass in something that's longer than 32,000 characters. I think I'm okay with that restriction. It can be ISBNs. I don't think I'm going to have a 50,000 character that someone's string that someone's say, is this valid for 10 digits? No. So I think integer is okay. I could probably get by with byte just fine. Okay, so now I got to have something. Let's start off by just making this print off each digit one at a time. So help me with that. What structure should I use to do that? Some kind of loop. What kind of loop should we use? We've got three kinds of loops. We've got the do loop, we've got the for loop, we've got the for each loop. Which one do you want to use? So for each, so we're saying for, so we're saying for each. I agree, do loop's probably not the best one here. In this case, remember that what for each does is it says I'm going to iterate across elements in a collection. I've got some set of different things. And so it turns out that a string isn't really viewed as a collection of different characters. In some languages it is, but not in VBA. It's just seen as a single thing. I can go look at them individually, but it's not already a collection of those things. And so I think a for loop is going to be the best one. So for x is just my control variable for the loop, equals 1, 2. Now, I got to look at every single character, starting with the first one, going all the way up until however many there are. So how do I ask how many are there? What's the function? Say it louder. Len. Yeah, so for the length of whatever got passed in. So up here, I'm going to be calling isValidISBN with this collection of characters, with this string of characters. That comes into the candidate. I'm then going to call valid digits. I'm going to pass that same set of characters down here. It comes into a variable called data. And so now I'm going to iterate from 1 to the length of data. By the way, what's length of data right here? It's like 13. It would be 13. So x is going to go from 1 to 13. Excellent. All right. Now, question.
I remember previously there was like an example we had where the set was a zero-based set.
Yes. So the question is, this sounds like you're using a one-based indexing scheme here, but we've seen some zero-based indexing schemes, and that's one of the things about VBA that annoys some people is that it's not consistent with the way it indexes. So like in other languages like Java, you're talking about the first character in a string, it's the number 0 character. And in VBA, it's the number 1 character. Somebody made that decision in the 1990s, and they thought it was a good decision. I'm not sure. There are definitely zero-based sets. We'll spend a couple of days talking about arrays, which by default are zero-based. Okay, so now what the student said here was, first thing we want to do is check to see if that, well, actually, first let's just print that off. So let me do a debug.print of, now how do I print just that one character? Why don't we do this? Let me declare another variable here called one character, or one char, as a string. I'll show that. I'm not going to ever test you on what I'm about to show you, but you might be interested. So strings, when I introduced the idea of a string, I told you it's a variable length data type. It can take a lot of data or just a little bit of data. If I know I'm only ever going to put a certain number of characters into that variable, I can do this little trick right here, *1. And that says, this is a string, it can only ever hold one character, it will always hold exactly one character, which means, remember the 4 bytes of overhead that it takes to keep track of how long it is? I don't use that. This actually takes 1 byte of memory to store that value. And again, that's beyond what I'm expecting you to know on any exam, but that's what it is. Okay, so I'm going to print one char, but right here I need to actually put just one character. And I want to make it so the first time through the loop, the first character is going into one char. The second time through the loop, the second character is going into one char, and so forth. So how do I do it? Talk to me in VBA. What do we got? I'll get started. One char equals. Okay, so you don't have to be so ambitious to start off to actually make it work for everyone. Let's just start off by getting the third character, and then we'll adjust it to work with the loop. So kind of hard code me to get the third character. In this case, it would be that 3 that I'm after. Go ahead.
You do like you'd have to embed a left into a right.
Ah, we could do it by embedding a left into a right. There's a more straightforward way. Mid, yeah, so let's try mid. So mid takes an argument, the string I'm looking at, that's gonna be one char. Now, it then says, where do I start? Start at the third character and take one character. And so now if I was to run, instead of doing is valid ISBN, let me do valid digits. And that should now actually print off 13 characters. And something didn't go right. Let me put a stop right here so I can kind of snoop around. I'll run this. And let me just see what one char is right now. It's got to be a 0-length string. But I'm not sure why. Oh, because not mid of one char, it's mid of data. Thank you, yeah. So we're looking at the data that was passed in. And let's go ahead and run that. There you go, it prints off, presumably it's 13 of these. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, and then that's it. So it's print off 13 threes. So now I don't want to print off the third character each time. Which one do I want to print off? Yeah, the first time I want it to be 1, the second time I want it to be 2, third time 3, and so that's exactly what x does. X counts from 1 to 13 in this example, so I'll put x right there. And so now when I call valid digits, it should print off all those digits one at a time. So now I've got that digit sitting in a variable that I can now start snooping around and deciding, is this valid or not? Ah, okay, so we're going to go ahead and print it off. We'll take that out eventually. Okay, so now there's a question here. Oh, hey, that's a really interesting question. Would this work? The question is, you made this a single character string. What would happen if we took the whole rest of the string? Just get the mid of x, and that would start with the first character. And the answer to that is, I don't know. But it's a really interesting question. So let me stop right here. And then let's play with it. So I'll run this. Okay, so the question is, what happens if I was to change one char and set it equal to 2 characters? A, B, C, D, E. Okay, 5 characters. Okay, so it executes okay. Now the question is, what's in one char? And I think your intuition is right. I think it's going to be the A. Yeah. So we actually could get by without telling it to take one character, because if we told it just to start at the different place and bring the rest of the string, once we put it into one char, the conversion to that data type would throw away everything after the first character. I like actually telling it one character because it says to a future programmer, I'm just pulling one character. And we don't have to infer anything about what's happening with the data conversion that VBA does in the background. Excellent, excellent thought. Thank you. Tell me your name. Catherine. You get a gold star for the day. As it turns out, gold stars don't help your grade at all, but they're nice to get. Okay. So we're putting all this out. Okay, so now the thought was, how can we tell if something is a number? I've got that one character. It's a string, so it's not a numeric type, but there got to be some way to ask, how can I tell if a string is a number, could be converted to a number? Whew. Well, one way is I could just try to convert it into a number, and if it doesn't give me an error, I know it was okay. Now, next time we get together, we're going to see how to actually handle that, like do something that might cause an error and then see if it caused an error and behave differently, but there's a more direct way. Go ahead. Oh, interesting. Okay, yeah, so the comment here is we could look at the ASCII value of it. Look at the ASCII value of one char, 97. Right now it's lowercase a, and so that's it. So now we could actually look, and there's a, what, do you know what the number is for 0? Like 0 to 9 is? So yeah, we could look at the ASCII value, and then we could do that. Oh, I like that way. That uses something I already taught you. We're going to do it a different way, so I can teach you something else. But that really would work. It's a pretty good approach. So I've never heard of isDigit. D-I-G-I-T. Yeah, it's not there. But there's one called isNumeric. So isNumeric, you give it a string, and it will tell you true or false if it's numeric or not. So 4 is not numeric. 4 is numeric, A is not numeric. How about space 4? What do you think? Numeric or not numeric? I think it's not numeric. It is numeric. So it actually looks at the space and it goes, you know what? I can figure that out. So it gets rid of the space for you. How about 4 point? What do you think? I don't know. I think it's probably numeric. Yeah, let me figure that out too. Like 4.2. It's okay. How about just the point by itself? What do you think? Numeric? I'm praying it's not numeric. Whew. Yeah, good. Because we expect to be able to take dots in here as well. So because we're only looking at one character at a time, we don't have to worry about it being a space and a 4 because we'll only ever be looking at one character. What do you think? Is the space numeric? Space is not numeric. How about a 0-length string? Think it's numeric? I hope not. No, good. So yeah, okay, so we could do that now. Now that we've got one character sitting here in one char, we can say is numeric. So if, make an if statement, if is numeric, one char. If it is a number, then we'll do something else. And what do we do if it's not a number? So here I'm just going to put it is a number. We got some work to do there. If it's not a number, what do we do? What's that? Okay, we're looking at a character. If it's a number, we go, hey, it's good, let's move on. If it's not a number, what do we have to do? I heard, we don't delete it. Is it an X? Yeah, the other possible valid character is an X. So let's do another if here. Else if, one word. And let's do this. If the U case of one char is equal to a capital X. I don't want to have to check, is it a lowercase x, and then look again, is it an uppercase x? Let me just take one char and push it to uppercase. Now this does not change the value of one char. It's just this whole expression equals the uppercase version of what's ever there. It doesn't change it. Otherwise, if the uppercase version of one char is a capital X, then we'll do something. It's an X. Else and if. Okay. We've got little spacing issues here. Okay, so now we have our structure kind of put in here. So here's what I'm going to do. I'm going to say if it's a number, then it is a number. Then all I'm going to say is my return value is equal to what it used to be concatenated with one char. So if it was a 4, we're just going to take the ret val, whatever it was, and concatenate a 4 onto the end of it. So the first time through, what is ret val? The first time I hit this line, I'm going to set a new value into ret val. What's its old value? It's a 0-length string. And I'm going to concatenate onto it one character. And that's just going to then make it one character. Great. So now, if it comes through here, what should we do? So this is valid. What should we concatenate on here? We could put one char, but we know one char is what? At this point, if I hit this line of code, what is one char? It's either a lowercase x or it's an uppercase x. We're not sure. And the truth is, I would like to not have to ever ask that question again in the rest of my function that I'm going to be writing up here to check it. So let's just send back a capital X. And it doesn't matter, it could be capital X, it could be lowercase x, but now we know it's only going to be 0 through 9 and then an X, either uppercase or lowercase, whatever we send back. We don't have to worry about case anymore about it. All right, question here? There's a U case, and that makes the uppercase version. There's an upper function in Excel, but not in VBA. There's an L case, by the way, as well. There's also a function in Excel called proper, which will give you the proper case, right? Capitalize the first letter of each word. There's nothing analogous to that in VBA. So if you really wanted to make something in proper case, then you could invoke the Excel function by using worksheet function.proper to get to it. Okay, now what do we do if it's not a number or it's not an X? Then what do we do? Yeah, just move on, nothing to do. So because there's nothing to do here, we don't even need the else clause. So if it's a number, we'll do this one. If it's an X, we'll do this one. Otherwise, just move on. We've looked at the character. It's not one we have to keep. It's not like we have to put it somewhere else, or the ones we're going to throw away. Right? We're just saying we don't need to keep it. Okay, so now I think that's pretty good. Let me put a stop right here. And let me run our code up to that point. So valid digits, pass this in. And let me just take a look here and see what retval is. Oh, that looks great. It got rid of, I think we had a hyphen and 2 dots in it. And it's got, are there 10 here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Yeah, it's all there. That looks great. I shouldn't have deleted my valid digits, so I want to play with it a little bit more. So now my, let me just go ahead and get this put back. So now my task is I actually have to do something to send the value back. I've now calculated the value. It's retval. This is what I want to send back. How do I tell this function to send it back? Yeah, this is a weird thing. I know no other language that does it this way. The way I do it is I set the name of the function equal to what I want it to return. And that will then make that function return it. So now I should be able to run this. This is saying print the results of valid digits. And that should just, oh, let me get rid of the debug.print in the middle here. And that should just return back the valid part. If I put a couple of A's here in the middle, it should just ignore them. I'm not sure I really should call that a valid 10-digit ISBN, but it meets our criteria, which is I'm only going to look at characters supplied that are numeric or the X. And we should check and see if there's an X in it. And so now that brings back an X is the third position. I put it way here in the middle. 0, the dot shouldn't go to 3. Oh yeah, look at that. All those get ignored. The X comes in, then the 0, 6. Yeah, so that's pretty good. So you see how a function can be really useful. I've got the algorithm defined here, and now I can send it different data to work on, and it sends me back the analogous information that I'm after. How are we feeling about this function that we've just created? Yes?
So I'm able to run the function through my intermediate window, but I can't run it. It's not, the macro is not showing up in Excel.
Okay, so the question is, I can run it through the immediate window, but it's not showing up through Excel. Now, what I think you mean is, if you come here and you try to play it,
I can't step into it.
yeah, it doesn't show up. And the reason that it doesn't show up here is because the only thing that I can just launch this way are well, I think function procedures would show up here if they don't have parameters. Because I have to just be able to say, I'm saying run this procedure. And in this case, I can't just run it. I have to supply it a value. Yeah. And so, but I should be able to see it over here. I should be able to ask just the digits here. What is it called? Valid digits. See, valid digits is showing up here. Tab, no, enter. Valid. Valid digits. I want to say, how do I tell it I want to use that? It's not tab. Valid digits, and then I can point it right here, and it should just return the digit part of that, right? If I change this and put an X as the last character, works great. Okay. Other questions about what we've done here? If you did want to run this, then you could do this. Let me just make another sub procedure up here that I could run. Sub function runner, or a function runner. So no, this one has no arguments. And then I could just say debug.print, and then I could put my test data in here. So instead of doing it in the immediate window, I could actually write that same thing into a procedure here. And so now this one I can run, just hit F5 to run it, or I'm not even sure how to bring that up. If I'm somewhere else and hit F5, it'll give me that list to choose from. Oh yeah, that's the one I want to run, and run it again. So that's kind of a handy debugging thing when you're making something that has a parameter. You can't run it directly, but you can make another one that you can run directly and pass the values that you want to test it with. Oh my gosh, we have like less than 15 minutes and we haven't even really started the function yet. Okay, we better get busy. So this is going to make our lives a lot easier. So now, and I think that was the initial thought was, if it's not 10 digits, at this point, if our candidate number, CN, is not 10 digits, we're done. So I'll just do that. If CN, if the length of CN, right, because we're capturing back the value that comes back from valid digits into this variable CN, if that length is different from, so that's how we say not equal to, 10, then exit function. Now, every data type has a default value. What's the default value for integer data type? 0. What's the default value for string? 0 length string. What's the default value for Boolean? False. So if I never set this to be true, it will return false. So here, I've never set it to be true. I'm exiting out of the function. So at this point, no reason to look any further. We're done. Okay, but now if I get here, I know we have 10 digits to work with. So now we know it's the right length. Now we got to check to see if it really is correct. So we're going to want to loop here again as well. So let me dim x as an integer. For x equals 1 to what? How do I know how far I got to go? Yeah, I know I've only got 10 digits to work with, but as it turns out, the algorithm only requires me to work with the first 9. So I don't operate on I'm trying to calculate the check digit, right? So I'm looking at the other 9 digits, and we'll work with those. Okay, so for x equals 1 to 9, and that's one of the great things about knowing that I've got the right, if I made it here, I've got exactly 10 characters to work with. I know I'm at least have how many digits I have to work with. Because what happens if I say for x equals 1 to 9, I've only got 8 digits I've only got 8 digits to work on. When I try to look at the 9th digit, it's going to say, hey, you're trying to look at something that doesn't exist. That'll be an error. Put the next in here. Now let me just go ahead and print off those first characters. In fact, maybe I've got to do the same thing. I've got to look at those one at a time again. So maybe I'll just declare a one-char the same way we did down below. Dim one-char as a string. Actually, I'm going to dim one-char as a byte. What kind of data can I put into a byte? I better do it as, I'm going to need to check to make sure that it's numeric as well. I'm going to go ahead and do it as a string, 1 byte, a 1 string. So as string *1, because it would be possible for me to get an X coming back in the middle of my set of digits. So I'll have to make sure I deal with that. Okay, so let me just go ahead and make one char look at, I guess I'll write it again. One char equals the mid of my candidate number starting at the xth position and taking one character. Now, as I'm looking across these first characters, if I bump into an X, the only thing it could be is a number or it could be an X. If it's an X, what do I know? In the first 9, if I have an X in the first 9, what do I know? It's invalid. So let's just do that check right here. If one char equals capital X, the only thing it could be is a capital X, then exit function. So at this point, if I bumped into an X before I got to the end, get me out of here. I still have never set it to true, so it'll return false. Otherwise, I'll move on. So now at this point, I know I've got a digit to look at. So now what I have to do is I have to add up, let me just start off by printing off the things I'm going to end up adding off. So debug dot print. I'm going to print off one char. If I look at my algorithm over here, that will be the 0 the first time through. And now I have to have 10, 9, 8, 7, 6, all the way down to 2. So the first time I want to have my one char and I want to see that 10. So I need some expression to put right here that's going to give me 10 the first time through the loop, 9 the next time through the loop, 8 the next time through the loop. What would it be? 11 minus x. Brilliant. 11 minus x. So because the first time through the loop, x is 1, so the expression 11 minus x is going to be 10. Next time through the loop, x will be 2. 11 minus 2 will be 9. So I'm going to go ahead and run this. Is valid ISBN. In fact, maybe I'll go ahead and put it in here. Debug.print is valid ISBN. And I thought I had debug.print x equals 1 to 9. Oh, I have this x in here. So let me go ahead and pull in valid data so we actually get there. Okay, so it's printed off my 0 and my 10, 3, 9, 0, 8. Is that what I'm supposed to have? 0, 10, 3, 9, 0, 8. Yeah, it looks great. The last one is 5, 2, 5, 2. Beautiful. So now I need to I've got to multiply those together and then add them up. So here's a little trick that may not be apparent straight away. Let me dim, I'm going to call this checksum. Dim checksum as an integer. That should be big enough. And then instead of printing this, I'm going to say checksum equals what it used to be plus, I'll put this in parentheses even though I don't really need the parentheses, one char times, and I do need to put the parentheses here. So first time through, checksum is going to be 0. It's an integer, so it starts off as 0. It's going to equal 0 plus 0 times 10. So it's still going to be 0 after the first one. Next time through, it's still going to be 0. So its new value will be 0 plus 9 times 3. So it'll be 27. And then the next time through, it'll be, its new value will be its old value, 27, plus whatever the next one in the series is. And so that should give me a checksum. Let me stop right here. That should give me a checksum that I can look at and examine. And it should be the intermediate step that we saw here, 130. It looks great. So I've done this part by making a loop that goes through and does it. Okay, so our next step is to take that, here's the 130, here's the 130, and to take 11 minus that mod 11. Whew. What's mod? Do you remember back in 4th grade when you learned long division? You said, you know, like 25 divided by 4 is what? It's 6 with a remainder of 1. And so mod gives you the remainder part of that problem. And so what we're doing here is we're going to say, all right, here's the 130 that we just calculated. We're going to take that mod 11. Find the remainder when I divide that by 11. This is helping me to figure out what do I have to add to it to make it equal 11. And I don't really need that 130 anymore after this, so I can just do that right here in checksum. Checksum equals checksum mod 11. So mod is an operator like addition or subtraction or multiplication, but it's actually written out MOD. So if I run this, that should give me checksum mod 11. This has to be between 0 and 10. Right? The remainder can't be the value dividing by. So now checksum is 9. And we can see that happening right here. So this comes here into this 9. So next I take 11 minus that. So I'll just do that in the next step. Checksum equals 11 minus checksum. I'll run that line. So now I've got 2, and we see that happening right here coming down to the 2. I take that whole thing, mod 11, and that's why don't I'm at this point, I'm going to call this a check digit because that's the end of the calculation. Dim check digit as a byte. And now I'll say my check digit is equal to the result of my checksum mod 11, which is the same thing here. And that should still be 2 at this point. And so now I've done it. I have calculated the check digit, and I'm ready to compare it to the last digit that I have right here. So now it's just an if statement. If my check digit is equal to the rightmost of, what do I call it, Cn. Cn is what comes back from my valid digits. If check digit is equal to the rightmost value there, then I'll do something. Else if check digit equals 10, here's a special case. If my check digit is 10 and the rightmost one off of that is equal to capital X, that is also a valid way. In that case, all I do is set the name of my function is valid ISBN equal to true in either one of these cases. And I could do this all in one if statement, right? If this is true or this is true, I think it's helpful to kind of split it up into the 2 parts. Either the check digit I calculated equals the rightmost character, or if I calculated 10 and that equals X. I think that's it. I think this now is complete. So let me go ahead and run this. This should return true. If I change any one of these characters, it should return false. And you could play with that and see if it actually does it. I know we rushed through this last part. I would like to give you a little more time to kind of come up with these steps with me. But if you'd like to look through it, You'll have it on the video. And the algorithm is different for the 13-digit ISBN, but the process is the same. All right, folks, thanks for coming. Class dismissed. You could clap. It would be okay to clap. Stop recording.